Okay, lesson 8.2, take 2. We just have 3 problems to do today, and they are complex fractions. You guys remember what that means?
Yeah. Fractions are complex.
Fraction with another fraction. Okay, so here's kind of the steps you need to follow. And actually, I was just grading my pre-calc kids test, which they actually did pretty well on. The ones that were trying to get out of it. And more of their mistakes, they had complex fractions, was like simplifying and rationalizing, like algebra skills. That was more of their mistakes versus like the pre-calc stuff. So this stuff's important, like knowing how to simplify a complex fraction like this. You'll be expected to do it pretty much from now on in your math career. So here's basically the steps to do it. Your first goal is you want to get the numerator and denominator to be one fraction, okay? So if I'm looking at my numerator here, I'm going to highlight it in yellow. I want to get this to be just a single fraction, okay? So I'll have to make common denominators and add those together. Same with my denominator. Same thing down here. I want to write those as a single fraction, and then it's just a division problem. You can keep, change, flip. Pretty much that's all to it. Before you can do the keep, change, flip, you have to get those to be single fractions, though. I could not keep, change, flip right now. All right? So the way I kind of do these, I kind of like separate them. So I'll use green here. So first I kind of will just draw like an arrow like this and say, okay, I want to write this as a single fraction. If it helps you to write 4 as a fraction, 4 as a fraction is 4 over 1. This one's not hard to get common denominators. All I have to change is the 4 and multiply the top and bottom by what? 5 to get common denominators, right? So I get x over 5 plus 20 over 5. So that'd give me x plus 20 all over my common denominator 5. All right, so there's my numerator as a single fraction. That part's done. Everybody okay with that? Sorry, I didn't mean to go too fast. It's just that one was pretty easy. Okay, now we're going to do the same with the denominator. So then I kind of do this. Like, okay, now I want to write the denominator. And if it helps you, you can kind of like section it off like this. Now I need to make this as a single fraction. Again, if it helps, you can write 8 as 8 over 1. What's my LCD here? Just x. Just x. Yep. So again, pretty simple one. I only need to change this first fraction times the top and bottom by x. And if you did your Alex homework, you should be pretty good now at making your common denominators, adding and subtracting. So this is going to be 8x over x plus 1 over x. Now we have common denominators. We're ready to add 8x plus 1 over x. Okay, there's step 1. Write the numerator and denominator as a single fraction, making common denominators. So now what I'm going to do is I'm going to rewrite this complex fraction with x plus 20 over 5 as my numerator. All over my denominator as a single fraction is 8x plus 1 over x. And now this is just a glorified division problem, right? So now we can keep the first fraction, x plus 20 over 5. Change the division problem to multiplication by timesing by the reciprocal. Keep, change, flip. All right, now this is a nice, easy problem to start off with because looking at all my numerators and denominators, there's no factoring I can do, and that's what we usually do is we factor first. There's no factoring I can do, so I just get to multiply these together. So you can, again, leave it like this. You don't have to distribute it through. You can just write your final answer just like that. I wonder if the answer key is there. If the answer key says this, like something like this. If the answer key, like in the back of the textbook, like says this, I'm okay with you leaving your answer like that. Just know and recognize, like, oh, my answer is the same thing. But I'm okay with you leaving it like in that factored form. I'm not sure how the answers are written. You guys will have to let me know. Okay, there's one. We have 2 left.
Two
They get a little harder.
Yeah,
Little.
But did everyone understand that process?
Yeah.
Write them each as a single fraction, keep, change, flip. All right. The nice thing about this one is look at my numerator. Already a single fraction. Holla. That one's done. My denominator, however, not a single fraction. I'm going to have to do some work here. What'd you say?
You don't have to factor the top one, like x minus 4.
We will eventually when I do like my keep, change, flip. But right now I first just have to write them as single fractions, and it's already a single fraction for me.
X minus 4 doesn't factor.
No, it doesn't.
Oh.
Also, don't think anybody tempted to like cancel these out. Don't do that.
I swear I was thinking.
Oh, I know what you're thinking. Okay. You were thinking that, James?
No.
Okay, good. Okay. So all I really need to do is work my denominator. And so I'm just going to come right down here and do that. So I have 1 over x minus 4 plus, this is a good review from yesterday too, 3 over x plus 1. So I got to find an LCD. My denominators are already factored. So what would my LCD be here?
X minus 4, x plus 1.
Good job, Sid. Yep. Be a combination of both my denominators. Okay, so now I got to make equivalent fractions. So I got to times the top and bottom by what they're missing. So in the first fraction, it'd be x plus 1. Second fraction, it'd be x minus 4. Okay, so remember with your denominators, you never want to actually multiply those together. We want to write them factored just like I have in my LCD, like so. And then my first fraction here, I just have 1 times x plus 1, which is just x plus 1. Second fraction, I see I have my LCD, and I got to do 3 times x minus 4, so just don't forget to distribute at that. That'd be 3x minus 12. Okay, now we're ready to add them together. X plus 3x is 4x. 1 plus negative 12 is negative 11, all over my common denominator. Woohoo! Step 1 done. I rewrote my denominator. Now it's a single fraction. Okay? So after I do that, I'm like, all right, I got my numerator as a single fraction divided by my denominator as a single fraction. You good? That's a huge thing of water. Do you drink all that in one day?
Yes.
2 of them. How many times do you pee a day?
Sometimes I don't.
How many times do you pee a day?
At least 5.
Oh, I was thinking way more.
Yeah.
Well, I
Well,
just
that's
hold
more
it. I just hold it.
That's less than me.
So then, like, I go for like a minute periods at a time.
Bruh.
That's a long time.
What's wrong with you?
You
Dang.
can't miss class though,
What?
because then you don't know what you're doing in the homework.
Okay, we're ready to keep, change, flip?
Yes.
Yes, we are, because I got a single fraction over single fraction. So keep,
Yeah. Yeah. That's right.
keep the first fraction, change to multiplication, flip
Wild.
the denominator. Wild. Is that what the cool kids say these days?
No.
Oh,
Tim
no?
just said it because he wanted to say it.
Oh.
You can go.
What's exciting about this?
Math.
X minus 4 by.
Ooh, look at x minus 4s. Now, we should have checked, but we can't factor anything here, right? All right, so my final answer, 3 x plus 1 over 4x minus 11. That's a perfectly fine answer. If an answer key says this means the same thing. And if you want to write it like this, that's fine. If you want to like distribute that through, you can.
It's not as bad as I thought it would be.
Oh wait, of course.
That gets a lot
That's the
worse.
next one. Oh god, not negative X.
I
minus.
saved the best for last.
Best is thanks, Nick.
You're welcome.
So this one we actually kind of have, this next one. we have a lot of fractions. Because x to the negative first, don't write this down, but this is the same as 1 over x,
Bro.
right?
Yeah.
So we have a fraction within a fraction within another fraction.
You got it.
Woofed up. Okay, so here's what we're going to do first. Here's what we're going to do first. I'm going to try to make this as easy as I can. First, let's simplify this fraction, just this piece, and then we'll come back to our numerator, okay? So whatever you need to do, circle, draw an arrow. Let's first just work with this piece.
Multiply x.
Because as I was saying, x to the negative first is the same as 1 over x. Right? X to the negative first is the same as 1 over x to the positive first. Okay. So let's go ahead and add these together. And this is pretty easy to do because 1 as a fraction is just 1 over 1. So what do I need to multiply the top and bottom by here? Yep. You will learn to love, even like in problems when we're doing like calc problems or pre-calc problems, anytime we're like adding 1, we're like, oh, such an easy fraction. You can literally make it whatever denominator you want, right? So easy. X squared over x squared. X plus 7 over x plus 7. You can manipulate it so easily. There's no really thinking to do. All right, so now we're here. 1 over x plus x over x. So that ends up being x plus 1 or 1 plus x all over x.
Shouldn't it be x squared at the top? Oh, no, you just want to the denominator.
Okay, now we can flip this. Your numerator is x divided by, change that to multiplication, the reciprocal. Everyone okay with that? Keep, change, flip. X, I'm only working within this piece. Ignore the rest of the problem for right now. Keep, change, flip. And if it helps you to write this numerator, because it's not a fraction, if it helps you to do that, you can. So I end up getting x squared over x plus 1. Just for that piece. With me?
Wait, could you just multiply by x over x? Like one on like the second step we did, and then it'd be fine. So instead of multiplying just the denominator, you can multiply both of them. Then you just get x squared over x plus 1 again.
Like you're saying multiply this by x and this by x?
No, like up like at the very first step where you have that, like can you just multiply the numerator and denominator by x, and it's x plus 1 over x squared.
No, because this is 1 over x.
Okay.
Yeah. All right. So here's what we have now. Let's write this right here. I have 2 over x minus x squared over x plus 1. The nice thing is, guys, look at my denominator. My denominator is a single fraction. Okay, here's where I'm at now. And I don't know if there's a better way to organize your work. I like to just kind of like section off numerator, denominator, and kind of work side to side. However, you can decide how you want to do it. So now I need to add these. Hey, that's not what I was trying to do. Undo. Now we need to subtract these or make these one fraction. That'd be our next step. Denominator's already done for me. That's the good news. It could have been worse. All right. So here we go. We got 2 over x minus x squared over x plus 1. Move this over just to make sure I have enough room to keep, change, flip. What would my LCD be?
X plus 1.
Good, Carter. X times x plus 1. Good. All right, so the first fraction, we'll have to times the top and bottom by x plus 1. Second fraction times the top and bottom by x. Everybody with me? Okay. In the first fraction, you have to distribute that 2. You get 2x plus 2 over your LCD. What's x squared times x? X cubed over my LCD. I always like to rearrange my LCD so that they exactly match. You don't have to, but. All right, almost done. Now we get to add these together. So what's that? Yeah. Oh, okay. Yeah. Subtract. I'm subtracting the x cubed. I want to put that one first. I want to put this in standard form. Negative x cubed plus 2x plus 2. Okay. So now my whole numerator is a single fraction. We are good on that. My numerator is a single fraction. My denominator is a single fraction. So here's what we have. Negative x cubed plus 2x plus 2 all over x times x plus 1. That's being divided by 3 over x. So as long as your numerator and denominator are one fraction, you can keep change flip. Keep the numerator. See why we have to do multiplication and division before we can do adding and subtracting? Change to multiplication, flip the denominator. Times reciprocal. Is there any factoring I can do here? Okay, well, we can cancel the x's, yeah. But factoring, I can't really factor this at all because I have that x cubed. So everything's factored, but yes, the x's do cancel. That's all that cancels. So I'd want to write this as negative x cubed plus 2x plus 2 all over 3 times x plus 1. Or 3x plus 3 would be fine too. I prefer the one that's circled, or squared, or boxed, or it's not squared, it's rectangle. Oh my gosh. All right, that's it for adding and subtracting. There is a worksheet that goes along with this that I will pass out at this time because I care about your learning.
What do you?
Why else would I be here?